So today we are going to look at state space a representation of a control system. So we have a question here, and the question reads: Consider the system below. It's a third order system. Okay, we have a differential equation here. It's a third order differential equation, and the question says derive the state space representation of the system. Okay, so let's start. So we want to represent this system, okay, in a state space representation. So state space representation is represented in this form. Okay, so you have the state equation, okay, which contains the derivative of the what, the state variables, okay, multiplied by the A matrix plus B multiplied by, B is actually the input matrix, right? U, okay, and then this is the state equation, and then we have also the output equation. Okay, we also have the output equation. So you need to understand that A matrix is an n by n matrix. So what is n? N is simply the number of state variables that you need to represent your system. In simpler terms, if you have a third order system, okay, it means that the matrix will be a 3 by 3 matrix. If you have a second order system, A will be a 2 by 2 matrix, okay, and then B is an M by M matrix, okay. So what is M? N have already explained. This is a number of what, state variables, not so. And then M is the input. How many inputs do you have? Okay, you may have U1 and U2. Okay, so U is actually the input. Okay, so if you have two inputs here, this will be n by 2 matrix. Okay, if you have three inputs, four inputs, and so on and so forth. Okay, and then we also have a C matrix. Okay, a C matrix. Okay, so just like this other matrix, okay, a C matrix usually is a 1 by n matrix. Okay, so n is simply what, the number of state variables, just like I explained. Okay, and then we have a D matrix. A D matrix is usually a constant. Okay, so usually it's a 1 by 1 matrix. Okay, all right. So now we want to represent our system in this form. So we need to describe this system using what, state variables. Okay, so what's the procedure? So let me just write the differential equation here. So this is third order differential equation. Okay, plus 2y. Now we don't have a non-derivative term, right? Y, right? So I'm going to put it just for the sake of putting it there. Okay, so that I have the decreasing powers, isn't it? And this is equal to u. Now what you're going to do here, since this is a third order differential equation, you need three state variables to describe this. So we're going to say, okay, let y equal to the first state variable, which is x1. Okay, so I'm going to call this equation number 1. In fact, this equation is usually the output equation always. Okay, usually. Okay, in some cases it may be different, but this one usually gives you the output equation. So I'll give this one as what, equation number 1, and then I'm going to take the derivative of what I've written here. So the derivative of y, okay, so I'll take the derivatives both sides. So this is a y prime. So actually derivative is presented by this dot. Okay, so you can even put dy dx if you like. Okay, actually it's a function of time, so to be dy dt. So it's up to you, but this is a simple way of presenting the derivative. Okay, and then this is equal to x1 dot. Okay, so after taking the derivative of this guy here, sorry, not x1 dot. Let me just start again. So let me say y dot is equal to x2. Okay, so I'm going to say y dot is equal to x2, and then y double dot is equal to x3. Okay, now you can say y prime prime dot is equal to x4, but look, we are saying that we need to use how many state variables? Only three state variables. Okay, so just have to end at what the second derivative. Now we need to describe now the derivatives again of these state variables. Okay, so now this time around we are going to take the derivative of what these equations. Okay, so take the derivatives of y. Okay, take the derivatives of y. Okay, so now what happens when we take the derivatives of y? What we need to do here, why are we doing this? We want to relate the derivatives of what? The state variables to the state variables themselves. Okay, so here's what we're going to do. So we're going to take the derivative of y here, isn't it? Okay, so this will be y dot equal to x1 dot, you're actually taking the derivative of both sides, isn't it? Okay, so if you differentiate this side, you have to do the same thing on the side of the equation. Now, if you look closely, okay, from this second derivative here, this second equation, okay, you see that y dot is simply equal to what? X2, isn't it? So this can be now written as what? Y dot is equal to x1 dot, which is same as what? X2. So from this now, we can see that we have related this derivative of state variable with a state variable itself, isn't it? So this is it, x1 dot equal to x2. So I'm going to label this equation as equation number 2. Okay, and then let's take the derivative of what? The second equation, isn't it? Okay, so the derivative of the second equation, this becomes what? Y dot dot, this is equal to x2 dot, isn't it? Okay, so y dot dot is equal to x2 dot. But if you look at the preceding equation, which is the second derivative there, y dot dot is simply equal to x3. So this is same as what? X3 as well. Okay, so from this we can say now that x dot x2 dot, sorry, this is equal to x3. Okay, this is equal to x3. So you name this equation as equation number what? 3. All right, now remember that we have to find the derivative of these state variables. How many state variables we have? We have 3 of them, right? So I've just only found the derivative of x1 and x2. We haven't found the derivative of x3. Okay, let's do the same thing. Okay, let's say, okay, what if we differentiate this guy, right? Okay, the last equation, y. So if you take the derivative of y double dot, this becomes y dot dot, isn't it? And this is equal to what? X3 dot. But don't say this is equal to x4 because you don't have x4. Okay, so here you need to be very careful. Okay, so this x3 dot has now to be, you have to get this x3 dot from where? From the original differential equation. Once you substitute here, so let's go ahead and substitute in the original equation. So let me just write the original equation. So the original equation is given by y dot dot plus 3 y double dot plus 2y dot plus 0y, this is equal to u. Okay, all right, now we said y double dot is simply equal to x3 dot, isn't it? Okay, so you have x3 dot plus 3. What is y double dot? Okay, so y double dot, if you notice, say y double dot is simply called what? X3. Okay, don't say x2 dot. What we are trying to do here, we're trying to reduce this third order differential equation to just first order differential equation. So here we just have one derivative, meaning the rest of the terms shouldn't contain derivatives. Okay, so this guy just be x3 plus 2. What is y dot? Y dot is simply called what? X2. Okay, without derivative. Okay, x2 plus 0y. What is y? Okay, this one I'm just writing just for the sake of writing. It's not there. Okay, but let's just write it. So what is y? Y is simply equal to x1 from the first equation as we defined it. Okay, so this is 0x1, isn't it? Okay, so if there's a number here, please make sure you put it. Now since it says 0, I'm I'm using it so that you can see how everything moves. Okay, is equal to u. Now let's solve for x3 dot, because we found x1 dot, x2 dot. What we don't have is simply x3 dot. So x3 dot is equal to, now the order of arrangement of this, start with x1, right? Okay, x1 start with a, and then x2 and then x3. You're going to see moment why I'm doing that. Okay, so this will be, if you move 0x on that side, just be, you can't say negative 0x1, just 0x1, right? It's the same thing. Okay, so this is 0x1, and then you have negative 2x2 minus 3x3 plus u. Okay, all right, so now we have three state equations. Okay, so the first one, x1 dot, okay, x1 dot was equal to x2, right? And then x2 dot is equal to x3, and then x3 dot is what we've just found, right? This is equal to what? 0x1 minus 2x2 minus 3x3 plus u. Okay, now let us write this, guys, in this form. Okay, in the state space presentation, right? Okay, so let's write that in that form. Okay, now don't forget the output equation, which is y. Okay, y is simply equal to x1. Okay, all right, so now these guys, okay, will form what? The x1 dot matrix, right? Okay, so we're trying to visit this matrix, this equation again. X dot equal to ax, okay, plus bu, right? So this x dot, actually it's a vector, isn't it? So you can expand this containing state variables. Okay, the derivative of state variables, right? This will be x2 dot, x3 dot, and so on and so forth, right, up to xn dot, right? Okay, okay, and then again this is a matrix as well, right? Okay, so this matrix is usually okay, may not be always the same, right? 0 1, then it's 0, just like that it goes. Okay, usually it's like that, right? 2 0 here, and then this is mostly 0. Okay, 0. Okay, until 1 here, right? Goes all the way. Okay, and then this is the some constant. Okay, so k1, negative k2, negative k3, until so on and so forth, right? Okay, until kn. So these constants that come here most of the times are those constants that you get from this differential equation here for x3 dot. Okay, you're going to see the moment, right? And then multiply by what? The x matrix is simply containing the state variables x3 until xn. Okay, plus, okay, and then the b matrix, the b matrix, okay, so the b matrix usually, okay, most of the times you have zeros. Okay, 0 0 until 1 somewhere there, okay, and then times U. Okay, that's a general way of representing that. Okay, so now here, since this is a 3 by 3 matrix, we have three state variables. It means that our x dot matrix will only contain x1, x2, x3. Okay, okay, don't forget these guys are derivatives, right? Okay, and then matrix A now, it also be a 3 by 3 matrix, of course. Okay, and then these are state variables here: x1, x2, x3. Okay, all right. So now from the first equation, x1 dot only what contains x2, meaning the rest x1 and x3 are 0. So what I'm trying to say here is that this guy can be written as what? 0x1 plus x2, there's only x2 plus 0x3, isn't it? Okay, you can also write like that. Even the other one can also be written as what? 0x1. This one also doesn't x2, so can add this as 0x2, but it only contains x3. So write the coefficients there, okay, in that order. Right, so this position is the position for x1, so there's no x1 in the first x1 dot, and then there's only x2, and then there's no x3, isn't it? Similarly, in the second equation, there's no x1, there's no x2, there's only x3. And then the last equation, you see that the coefficient of x1 is equal to 0, the coefficient of x2 is -2, the coefficient of x3 is negative what? 3, isn't it? Okay, so 0, negative 3, is it negative 3? Negative 2, sorry, and then negative 3, okay? And then plus U, or sorry, B, right? A B matrix, you also have to, since this guy is a 3 by 3 matrix, like the inputs are 3, I mean, sorry, you have 3 state variables, and there's only one input. It means that this matrix will be what? Okay, n by 1, right? It's a 3 by 1 matrix. I say that this matrix B is usually n by m, isn't it? Where m is the number of inputs that you have. Now, since we only have one input, which is u, then this will just be 3 by 1 matrix, okay? So let's write a 3 by 1 matrix here. So as you can see, x1 dot is independent of what? U, okay? X1 dot doesn't have u, isn't it? There's no u attached to it. So it means that this position will be 0. Similarly, x2 dot is also independent of the input, okay? So we put 0 there. Or x3 dot is dependent on the input, isn't it? So as you can see, what's the coefficient of the input? Simply equal to 1, isn't it? Okay, so put a 1 here and then multiply this guy by the u. Then this is what you call state equations, okay? Equation. So this is state equation, okay? Now let's write the output equation, okay? So the output equation will come from this guy, okay? This output, because we're trying to find the y, right? As output, isn't it? So the output equation, remember, generally is written as what? Y is equal to cx plus d. But if you notice here, you don't have a d, you don't have a constant part, isn't it? So meaning that the output here would just end up to cx, right? So what is C matrix? Okay, C matrix is a 1 by what? 1 by n, right? So you notice that so this matrix in this case is 1 by n, so n is simply 3, right? So this should be a 1 by 3 matrix, right? Okay, a 1 by 3 matrix. So you notice that this guy is on dependent on x1, isn't it? Okay, y is on dependent on the x1, so we're going to have the position of x1, where x2 is equal to 0, and x will be equal to 0, and then multiply by what? The state variables, which are x1, x2 up to x3. Okay, so now this is the state space presentation of our differential equation. Okay, thank you so much for your time.